Hello, hello, hello. Gotta do that. Sound check. Sound check. Here we go. Okay, pretty sure it works. Okay, so I'm gonna do the Chapter 2 test review here for you. It's got 20 questions, which is a lot, but I think some of them will only take a few seconds here, so hopefully it's not a super long video. Okay, here we go. Alright, first one says 6 times the sum of a number and 4 is 2. Your problem's going to look similar to this. I've seen it say sum, I've seen it say difference, and there's one other thing you got to be careful of. Mine starts with the word 6 times the sum. If yours starts with a number that is times the sum, that means you're going to use a parenthesis. For example, I'm going to write 6 parenthesis, and then in the inside I'm going to write the sum of a number and 4. They want me to use y, according to this right here. So the sum of y and 4 is 2. That's it. So 6 times the sum, so 6 times, and then inside the parentheses, the sum of a number and 4 is 2. So yours might say the slightly different word. If it had said something like the sum of 6 times a number and 4, I wouldn't have used the parentheses. If it said the sum of 6 times a number and 4 is 2, I would have written that. But if it says 6 times the sum, it's a little bit different. And I'm just mentioning that because it could go either way for you when it's problem time, okay? Alright, that was it. Done. Next. This one says solve, simplify as much as possible. I will show you how to do it with work by hand, of course. So give me a second here. Boop. And paint. Get my righty board here. Today I'm using my right monitor, so it's hopefully not too screwed up. No, I have to write a little righter than I'm used to, but I guess that's okay. So 2x plus 12 equals 28. So hopefully you know these steps. I mean, I'm just going to go through it like you know it. I would minus 12 on both sides. Get 2x equals 16. Divide by 2. 16 divided by 2 is possible, so it equals 8. There you go. 8. There should be a couple problems like this on here. I mean, I hope you have that basic one mastered. Although the basic ones can include what I had a second ago. It had a lot of positive stuff. Here, this one has more negative things in it, so be careful with your signs and all that. So here's a very similar problem. So first I'll get rid of this 3. I'll add it. Be careful. This is calculator work if you're not sure. Negative 1 plus 3 is negative 8. 2v. Divide by 2. Negative 4 equals v. So on my answer, v equals negative 4. Okay, another one. So 4u minus 8 equals negative 16. So I'm going to add 8 to both sides. I'm going to give 4u equals negative 8, because negative 16 plus 8 is negative 8. Divide by 4, and u equals negative 2. Easy peasy, right? I hope so. And this. Okay. Continue. Hopefully you're able to get that much. Like, if you can do those 4 problems, those are like the stepping stone to everything else. Not to mention, that's 20%. I know 20% isn't a great score, but if you can do that 20%, all you need to do is extend your knowledge a little bit for everything else. Like, this one's almost the same thing. It's just that you need to distribute first. Or not distribute first. There's ways to do it without, but I'm just going to assume you want to distribute. So let's just do it as if you did, because there's nothing wrong with actually doing that. So if I distribute the 3, I get 3 times 2 is 6w, and 3 times 9 is 27. And now it's just like the other problems I did a second ago. I add 27, 6w equals 42. I divide by 6 on both sides, and w equals 7. I should stream with this side more often. This way I don't block any of the writing with my head. Alright, so that one we just did had distribution on it. You're definitely going to see one of those, okay, on your test. You're also going to see one like this one, where it's got a fraction, like all over something, You don't want all over something. That actually blocks it. I can't do anything about 2x and 19 because the 3 under there is kind of ruining it. So the first thing you do is you multiply by whatever was being divided, in my case 3. That gives me 2x plus 19 equals 15. Then I'm back to doing normal steps. I minus 19 on both sides. 2x equals negative 4. Divide by 2, and x equals negative 2. So this one just has the extra step of that division needs to be undone by multiplying first. You got to be careful, make sure you do that. Otherwise you can mess it up. Number 7. Okay, now we're starting to get into... That was all that other stuff was chapter 2.3 or less. This is where we're getting to 2.4. So we have multiple things with variables. So this one should be something like yours and something like you'll see tomorrow, assuming you're watching this the day before the test, not after. I don't know why you would, but whatever. So if they're on the same side, 10 and 3, you actually don't need to add anything to either side or subtract anything. You're just going to combine them. Literally, if they're on the same side, what's 10 minus 3? 7x equals 21. Divide by 7, x equals 3. Simple. If they're on the same side, combine them immediately. Don't add or subtract anything. Just do one with the other. Bada bing, bada boom. But then you're going to get some that are like this next one. These numbers are not on the same side. Oops. I can't say oops anymore. If I say oops, I'm going to say afterward. I'm ruined. Alright. There we go. Okay, now the last problem, we had 10 and negative 3 on the same side, and they can combine, but here 12y and 9y are on different sides. I can't combine those. And 14 and 16 are on opposite sides. I can't combine those. But what I can do is remove some of them. So, for example, this 9, I could subtract 9y. By doing that, this left side becomes 14 plus 3y equals negative 16. Now I minus 14 on both sides. 3y equals negative 30. Divide by 3, and y equals negative 10. Hooray! Oh, there's another one of those. Okay, cool. I put 2 of those. 6u, that's a perfect 6. Looks beautiful. 6u plus 9u equals 9u plus 14. This time I'm going to subtract 6u. Notice I'm taking away the smaller thing. Always whatever the smaller thing you should get rid of, including a more negative thing. You don't want negative things, so it's better to get rid of the more negative thing. Or in my case, since these were positive, I got rid of the less positive thing. Okay, I'm doing all the normal steps here. So I moved 6u to both sides, from one side to the other side, essentially. 9 minus 6 made 3. Then I minused 14, and then that became negative 12, and I divided by 3, and then that made negative 4. The end. You have to excuse me if I seem like I'm rushing. I'm not trying to rush. I mean, it shouldn't take too long. Hopefully this takes me less time than it takes... Hopefully it takes me more time than it will take you on the test, because I'm trying to like explain it a little bit here. On the test, if you know what you're doing, you'd probably be writing the same thing at the same speed. I mean, I know I'm the math teacher, but I believe you can do that. So I distribute these 7. I get 7u plus 21. So in this case, if there's a parentheses, you got to distribute that first. Then do the normal stuff. I take away the lesser variable, so I take away 3u. 1 equals 4u plus 21. I would like to minus 21 on both sides. Negative 20 equals 4u. And divide by 4. And u equals negative 5. So same kind of stuff as everything else. You got to just distribute first before you combine stuff and move it and all that good stuff. We're cruising. We're on question 11. Alright, so question 11 is a word problem. Now, the key to the word problem isn't like you solving it. I know you could probably handle that, and that's the thing people can handle, but what they can't handle usually is the setup. So I'm going to be deliberate on this one. Go right to the end. Answer the question. For how many minutes of calls will the cost of the two plans be equal? So there's here's what's going on. I know there's minutes of calls. That's a thing that probably we don't know. I know there's going to be a cost of those things. There's two different plans, and I want to know when they're equal. So I'm going to start the problem off by going to my scratch paper here and putting an equal sign. I know something's equal here, so what? What two things equal each other, but what are the things? Well, the two plans. So let's go back and read about the two plans. The first plan has a $29 monthly fee, and it charges 15 cents per minute of calls. So I will do $29 monthly fee, 15 cents per minute of calls. Okay, cool. And then the other plan has no monthly fee, but it charges 19 cents per minute of calls. So this company charges you more per minute to call, but you don't have that extra fee. So it says, when are they equal? And so I've done it. I've said one plan equals the other plan. Then you solve. I minus 15m, I minus 0.15m. I get 29 equals 0.04 m. Then you divide, yes, by a decimal, 0.04. 29 divided by 0.04. I guess I'll use a calculator. 29, 0.04. 725. Ah, of course. And there you go. So it's all about the setup. If you can get the setup, I'm sure you could do the other steps. It's very much like anything else we've already done. Alright, now we're getting to some stuff I saw a lot of people struggling with. I saw a lot of people missing this and that here and there, so I want to make sure that you are very clear on this one. Absolute values. So the trick to absolute, not really a trick, the key to absolute values is that there's two solutions, almost always two solutions. In the very rare case that this 5 had been a negative 5, I would pick no solution. Okay, but I get the feeling that based on what I've seen on Alex, a lot of the time you get a solution, and here's how you find it. First you write what you already had, no absolute value signs. Then you write a second problem, just like you already had, 5x plus 10, but it needs to equal the opposite of the outside, in this case negative 5. You'll solve the first one, which is 5x equals negative 5. Divide by 5, x equals negative 1. Great. I'm not done. I got to go get the other one. And for anyone who still thinks this way, please, it's not 1 and negative 1. No, no. I mean, that's kind of possible, but it's probably not going to be the case. You basically need to do two problems in one. And I know that's probably not something you like to hear, but that's too bad. Okay, negative 3 comma negative 1. Two different answers. Okay. Alright, another one here. Oh man, that is unfortunate. I was hoping to see one kind of like what I saw more people having in class. I might even do a side problem just for anyone who's watching. Alright, I'll do this one though. W minus 8 plus 8 equals 20. Now on this one, you know that last one I split it into two problems? This one you got to subtract anything or add anything or multiply or divide anything. Whatever's not in the absolute value, you got to get that out of that side, you know what I mean? So this 8 that was outside the plus 8, I have to remove that first. So the leftovers will be W minus 8 equals 12. Then you can split it into two problems. W minus 8 equals 12. W minus 8 equals negative 12. Good news here is that it's only one step. I just need to add 8 to both sides on both problems. So we're going to get W equals 20. W equals negative 4. There's your answers. Negative 20. No, regular 20. Negative 4. Okay. Be careful with your signs. I'd hate it if you missed a problem because you didn't put a negative sign. Alright, I'm going to do one more over here because I feel like you should see it. A lot of people had this, and I hate to show you my one example and not show you something else you might see. You might get a problem like this. Negative 3, x minus 2, negative 27. There, perfect. Great problem. The negative 3 on the outside here is multiplying to the absolute value, and you can't have this here. You can't distribute it. Absolutely don't distribute it. You have to get rid of this by dividing both sides by negative 3. And that does two nice things. First thing it does is it gets that 3 out of there. And the other thing is the right side was negative, which is usually a no-no that you'd pick no solution over. But because you divided the negative by a negative, it becomes a positive, which is actually a nice thing now. And then you can go to solving it like you did on the other ones a second ago, adding 2 to both sides. And then you get x equals 11 and x equals negative 7. Okay, that wasn't even a problem. I wasn't even doing it. But I just wanted to show you one with this number outside, because I saw a lot of people with that, and I would be sad if you get one of those and you hadn't been at least able to see me do one, you know? Alright, next problem. Alright, now we're on to proportion problems. Yay, proportion problems. They're actually kind of easy, honestly. All you do is you cross multiply. So 8 goes to 5, that's 40. 11 goes to x, that's 11x. Then to solve for x, you need to divide by 11. And the answer is 40 over 11. And I think this is going to be the case on the test. Like, if you write 40 over 11, to me, that is correct. But on the test, apparently they want that as a decimal, rounded to the nearest tenth, specifically on this question. So I'm going to get 3.6. So just this one, it looks like you want to round it. These other ones, you do not want to round it. You want to do like a fraction of an answer. Oh, there's little toddler arguments going on out there. I gotta shut the door. Mommy's taking care of that situation. Alright, we're going to do the same thing here. We're going to cross multiply. 5 times 2 is 10. Here, 3 is going to multiply to that top stuff. You got to be so careful to do it all. 3y and 15. The y gets times by 3, and the 5 gets times by 3. Then you add 15. That's a 15. You add 15 to both sides. In my problem, you get 25 equals 3y, and then you divide by 3. And you can't actually divide 25 by 3. It's going to be some kind of decimal, repeating decimal. So this problem is actually okay if you just leave it as 25 over 3. Because it doesn't say round to the nearest tenth or anything. The next problem, even more proportions, except for this one's a word problem. It says Rachel runs 5 miles in 38 minutes. At the same rate, how much could she run in 57 minutes? So what you want to do is you want to set up a proportion problem. And how do I know it's a proportion problem? Because we're talking about like the same rate. That's usually referring to something per something. Like she runs 5 miles per 38 minutes. At the same rate, how many miles, we don't know, could she run in 57 minutes? And then it's just cross multiplying. Fun again, 38x. 5 times 57 is 285. Divide by 38. And you get x equals, I don't know, I got to do 285 divided by 38. 285, 38, 7.5. Oh, a nice number. They're probably going to give you a decimal that has like, at worst, a decimal with maybe like a digit or something like that. Nothing too crazy. Okay, next problem. Alright, this one is yet another one. Now, a lot of people have been doing this with mental math. You could do this one without mental math too. So I'm gonna do it with the actual math. It says the scale of the painting is 1 centimeter to 6 inches. In the scale drawing, the length of the painting is 7 centimeters. How many real inches is that? Now, this isn't too hard to figure out. You don't even need to cross multiply. If you can figure out what turns 1 into 7, you can figure out how to change 6. 1 times 7 makes 7, so 6 times 7 makes the new number, 42. And then we're going to use the same logic on the other one. So the scale is 1 to 6. You want to use the same scale again. The height of the real painting is 24. Now be careful. The top is the scale. The bottom is the real. So in this case, 24 is on the bottom. The unknown is on the top. I'll call it y. So again, same logic. 6 times 4 is 24. 1 times 4 makes the other thing, which is 4, obviously. So using a little bit of logic or setting it up for cross multiplying is all good stuff. Okay, we're getting to the final 3 questions. Hooray! We got 1-dimensional analysis and 2 literal equations. And I know how much you guys love all of those things, so let's take it slow. Alright, so it says a cyclist rides a bike 5 meters per second. What is the speed in kilometers per hour? You are very likely to get a question that asks you to switch from one speed to another. So 5 meters per second. And you'll notice I'm writing very deliberately, 5 meters per 1 second. Now your goal is to turn that into kilometers per hour. So first thing you do is you multiply it by a new fraction. That turns the meters into kilometers. And you'll notice I'm writing it like this. I want to write it in a way so that the meters is on top and bottom so they cancel. But now I have to write something true. How many kilometers is how many meters? 1 kilometer, 1,000 meters. You don't know how many meters is in a kilometer? I'll probably write it on the board for you. Okay, then you have to turn seconds into hours because I want kilometers per hour. What I recommend you do is this. Write 60 seconds is 1 minute. This cancels out seconds, but it still doesn't get us to an hour. Then you write another one. 60 minutes is 1 hour. And there you go. We've got the setup. The fractions are all ready to multiply because we have kilometers only on top as a word and hours only on bottom as a word. So we do 5 times 60, which a calculator will tell you is 18,000. And the bottom is 1,000. And then you divide those and you get 18. Yours is... Mine was easy, quote-unquote, to mental math. Yours might not be so easy. So the speed is 18 kilometers per hour. If you want to know the distance of 2 hours, you simply just, or however many hours, or however much timing you do, you'll multiply that by what you got. 18 times 2 is 30. I didn't even write a close number. 36. There you go. So the setup's a little difficult. You write your starting fraction, and you will need to multiply a few fractions. My thinking is you're going to probably need to multiply 3 things. Something that turns your distance into a new distance. Maybe meters to kilometers, or miles to feet, or something like that. And then you're going to need to change probably hours to seconds or seconds to hours. That's what I've been seeing on every other problem, so be prepared for that, okay? Okay, now for your favorite literal equations. So let me write this down. C equals 6 y minus k. Please be aware of what you're trying to solve for. Mine says solve for y. So I want to get this y alone. Do you want to distribute? Okay, I'm going to assume you distribute. I'm not saying you should, but you can and still be right. So I'm going to. So I get 6y minus 6k. And then the question becomes, how do I get this y by itself? Well, normally you add or subtract first to get something out of here. You can add 6k. It's totally fine. This gives you c plus 6k equals 6y. Yes, I can't combine the c and the 6k. They just have to be written separately, side by side. Then the next step is to divide by 6. If you divide the right side by 6 like I did, divide the whole left side by 6. And that's literally the answer. It's not a number or anything. You literally write c plus 6k all over 6. Be very careful. Make sure you put it all over 6. And be careful. I'm writing capital C here. I've checked and I've watched people do this. If you don't type the right capital or uncapital, it doesn't mark you wrong on the homework. I have no idea if that's going to be the same case on the test. Okay, so be super careful. Put the capitals that are capital. Put the lowercase that are lowercase. Okay. Okay, next one says this d equals 3m plus 4n, and then you're going to solve for n. So I want to get 3m out of here. So let me minus 3m. This one's kind of like the last one, but with nothing to distribute first. D minus 3m equals 4n. And then you divide by 4. The whole left side goes over 4. There, you're done. That's it. D minus 3m all over 4. If you're wondering how I'm getting this to go all over, by the way, if you type over 4, you'll get this. If you select it all, then hit divide, then it puts it all over that, all nice and neat for you there, okay? Alright, I went at as reasonable a speed as I could. I hope it was enough. I hope you just skipped to what you needed. It was 25 minutes here. I don't want to go through the whole thing again, but I'll recap generally like this. The first 8 to 10 questions were all just solving like two-step equations. So you're doing like add something to both sides, subtract something on both sides, then divide or multiply. Who knows? Maybe you need to just multiply first, then you need to subtract. I don't know. It could be any of those things, right? The first question is a little bit different, though. That one was to write an equation. Then the last half of it had a big mix. It had a mix between doing absolute values, which you have to split into two problems, proportions, where you have to multiply, cross-multiply. Then there was dimensional analysis, where you have to do that fraction thingy, and then these two questions about literal equations. Okay, so if you're good at solving equations with just getting a number, you're at least guaranteed to be half good. But if you can get your way through a good amount of these other ones, you're going to be in good shape test-wise, okay? All right, that's all I got for this. I hope you enjoyed that and it helped you, and I'll see you next time.